Hello and welcome to all maths students. Today in Maths Plus we're covering an area problem. So there is a number of parts to it, but it's a really nice question and you're going to learn a lot of skills during the question. So we want to find the area which is between the three circles. Okay, so we have two similar circles, A and C, and then we have a smaller one up above, B. So we want to get this central area. We have some other information too. We have side 3 and 3. Okay, they're the radii of the two circles. And we also have a right angle up here. So let's see how we're going to solve this problem. Right, so the first step would be to introduce a new variable r, as we want to find the unknown, the radius of the smaller circle. So if we look carefully at this triangle, you can see that we have a right angle up here. Okay, and we have a length here, and we have two similar lengths here. So that means that we have one unknown, and also we can use the Pythagoras theorem. So let's put all this together first of all and solve for r. So if we use Pythagoras theorem, and you can visualize the right angle across from the hypotenuse, we can say that 6 squared is equal to the sum of the opposite side squares, 3 plus r all to be squared, plus again 3 plus r all to be squared. So let's work this out. So we have 36 on the left hand side, which is 6 squared, and on the right hand side we will have two sets of brackets with 3 plus r all to be squared. So far so good. So now we want to simplify more, so we can divide both sides by 2. Okay, and that's going to give us a 18 over here, and we have 3 plus r to be squared on the right hand side. So let's square everything out and let's create a quadratic. So we get 18 here. Okay, there's no change. So when we square it out, we can multiply 3 plus r by 3 plus r. And then we can split the brackets. So we're going to get 3 by 3 plus r. So that would be this first element multiplied by the second bracket and distribute the r as well. So we're going to get plus r by 3 plus r. Again, we have 18 over here. So we have 9 plus 3r plus 3r plus r squared, and we have 18. So we can bring the 18 over and we can put 0 here, and we can put everything together now. So r squared can go at the start. Okay, we want to create quadratic form, and then we can bring in the 3r plus 3r, which is 6r, and you guessed it, bring across the 18, subtract it from the 9, and we will get minus 9 for our number. So that's the quadratic form. So what do we do now when we have it in this format? So if we look at it closely, it is difficult to factorize it, as the roots will be decimal values. It wouldn't work out. So therefore we could use the Pythagoras theorem, or we can use the minus b formula at this stage. So we can now assign a, b and c for the coefficients of the r squared, the r and the number respectively. Okay, and we can input them into this formula, and this will give us the values of the roots and the solution for r. So let's put that all together. So we can say R is equal to, up on the numerator we have minus b, so we have minus 6 plus or minus the square root of b squared, which is 6 squared, minus 4 by a, which is 1, by c, you've guessed it, it's negative 9, all over 2. So you can put this into your calculator, use the fraction button, this button in your calculator, and it will work out. Do the plus first and then do the negative. In this case we're taking the plus because we want to get a positive answer, because we're dealing with area and linked. Okay, so we just want to get the actual rational value. So R will be equal to minus 6 plus, so if we get 6 squared with the minus 4 by the minus 9 by the 1, which is the square root of 36 plus 36, which is 72, all over 2. So let's see what this works out as. So we'll work the 2 decimal place to maintain accuracy. So when we input this into our calculator, we will get R is equal to 1.24 rounded. So let's stick with that value for now, and we'll go on to the next section. So we're working out the area in the center, and we're going to assign the S1, S2 to the larger sector areas which are overlapping in here and in here. So if we find those areas, we can subtract them from the overall. So let's see how that's going to work out. So it's coming together now. We have R, and all we want to do now is get our angles and our areas of sectors. So we need to use this formula to get the area of a sector. So before we use the formula, let's just mark in the values we have so far. So we have R plus 3, which would be 4.24. That's R plus 3. Okay, this angle is 90. The triangle is isosceles, so that side and that side are the same. And the base angles will be the same as well. So we're going to get this angle here will be 45 degrees, as if we call this side Y and this side Y, and we can say that 180 degrees minus 90 is minus 2y is equal to 0, or else set them equal to 0. Well, therefore y is equal to 45 degrees. Alright, so we have everything we need now to use the area of sector formula, and let's have a quick look at this formula now. So we have pi, we just use that as a constant. We have the r squared, so that this would be the r here and this would be the r up here, and then we're going to put in the angle then. So let's work out those sets of areas, and that will help us to further the problem. Okay, so area of S1 will be pi by 4.24. Well, we can go with 3 here because it's the smaller side, so we just go up here at side 3. So 3 squared by 45 degrees. You can see where that's coming from. That's the y value we worked out earlier. Okay, so that's going to be that angle here. Okay, so let's work that out and let's see what we get. So we get A is equal to pi by 9 by 1 over 8, which is equal to 9 over 8 pi. So that's the one of the areas. So let's get two S1s, two of those, because we're going to bring it. So 2S1 will be equal to 9 multiplied by 2, 9 over 4 pi units squared. Okay, that's awesome. Now we have the first area, so we can follow the same procedure with the same formula for S2. Alright, so we're up here now with this one. So the radius here will be the R we worked out earlier, so we really needed that one. So area S2. So maybe you can follow this and try this yourself, as is good practice. So area is equal to pi. So now we'll put in the 1.24. We have to square that, and the angle is 90 over 360. Okay, so we can use that angle, okay, as a proportion of the circle. Okay, so let's see what we get. So area, so we leave it in terms of pi just to make it simple, make it appear straightforward. So the number works out as 0.38 rounded pi with a units squared. So this is really good. Now we have the sectional areas within the triangle. We have the overall side length of the triangle. So now we have to come up with a plan to put all these parts together to get the internal area. So this is our plan. So we're going to get the total outside area over here, this larger triangle. So these sides are R plus 3, R plus 3 and 6. Over here then we're going to get the three sector areas summed together. Okay, and we will subtract those from the outside to get the inside. Okay, so now we have a plan, so we must execute the plan. So the area of the perpendicular of the larger triangle will be half the base by the perpendicular height. So if we have a right angle in here, okay, we can visualize that as being the base. Okay, and this would be the height then. Okay, it makes sense. Okay, so the area would be equal to a half by R plus 3 by R plus 3. So we know R plus 3 is 4.24, 3 plus 1.24, and when we multiply it out, okay, we can square it. So our result will be 9, or well, we can go with two decimals again, 8.99 units squared. Okay, so that's the overall area of the internal triangle. Now let's sum up the three sectors, S2, and the two similar ones, S1 and S2. So we're going to sum up. So we will have for the two S1 and S2, or the S1s, okay, these, we're going to get we have a result already of 9 over 4 pi, and then we have to add the S2, okay, and we will get 0.38 pi. Okay, so let's subtract all of this. We subtract them from each other, and we're going to get an area of 0.73 units squared in the center. Okay, so we subtract those two, S1 plus the S2s, well that's two S1s, it's 2 by S1, and we will get a result of 0.73 units squared. So that's really awesome. So thank you for watching Maths Plus. It's been a really good question, and look out for more exciting videos. Thank you very much.